Today we will discuss a new topic of air conditioning system, which is design of duct and air distribution. In duct, design of duct, nowadays central air conditioning refrigerant system is used in hospitals, institutions, malls, theaters, etc., where large amount of area is to be cooling. With the use of air conditioning system, we can condition this large amount of area where air is carrying from refrigeration air conditioning equipment to the conditioned space and conditioned space to the refrigeration air conditioning equipments by duct. The most important is design the duct with air distribution. First of all, we are introduce the duct. The duct system is the conditioned air from air conditioned equipment to the proper air distribution points in the room and carry the return air from room to the air conditioning equipment for recirculation or say reconditioning. When the conditioned air cannot be supplied directly from the air conditioning equipment to the space to be conditioned, then the duct are installed. Basically, different types of duct is used, like rectangle duct, triangle duct, circular duct, etc. We design the duct. When designing an air conditioning duct system, required airflow are known from load calculation. The duct system is required to be designing in such a way that the capital cost of duct and the cost of running fan should be lowest. This is a introduction of duct. Then second is a function of duct. The function of duct is to carry the air from air handling equipment to the space to be conditioned. Next function of duct is to friction losses, velocity, sound level and heat leakages losses and gain. The air conditioning must be properly distributed to provide conditioned room. This is a function of duct. One more function is duct system are also used to bring cooled or warm air to the proper distribution points where several rooms are to be conditioned. This is a different function of duct. Next is a classification of duct. According to, we classify different way of duct. Basically, three types of duct is used. First is according to velocity of air. According to velocity of air, low velocity duct and high velocity duct is used. In low velocity of duct, velocity of air should not more than 12.5 meter per second. The duct is known as a low velocity duct. High velocity duct, the velocity of air should be greater than 12.5 meter per second, the duct is known as high velocity duct. Low velocity duct and high velocity duct. Second, according to pressure duct. In pressure duct, we classify low pressure duct, medium pressure duct and high pressure duct. In low pressure duct, static pressure in the duct is less than 50 mm of water gauge. The duct is known as low pressure duct. In medium pressure duct, the static pressure in the duct is in between 50 mm to 150 mm of water gauge. The duct is known as medium pressure duct. Third one, high pressure duct. When the static pressure in the duct is from 150 mm to 250 mm of water gauge, the duct is known as a high pressure duct. This is a different pressure duct is used. Third one, according to type of air. According to type of air. First, supply air duct. Second, return air duct, and third one is fresh air duct. Three type of air duct is used. First is supply air duct. It supplies the conditioned air from the air conditioning equipment to the space to be conditioned is called supply air duct. Return air duct, it carry the recirculating air from the conditioned space to the air conditioning equipment, means air returned back to the air conditioning equipment. Third one, fresh air, it carry the air from outside, means atmospheric, it carry the air from atmospheric. This is a classification of duct. Next is a factor affecting the duct, design of duct. Factor affecting the design of duct. Basically 4 factors are affecting in design of duct. First is heat gain and loss from the duct. Very most important. Heat gain and loss from the duct. Second is aspect ratio of the duct. Aspect ratio of the duct. Third one is duct friction. And fourth one is type of fitting. First of all, heat gain or loss from the duct. The heat gain or loss in the supply and return duct system is occurs due to the duct passing through the unconditioned space. The allowance must be made for duct heat loss or gain in load. Second is aspect ratio of the duct, most important. I will draw one diagram of rectangular duct. This one is your larger side and this one is your height, means smaller side B, A and B. The aspect ratio of the duct is defined as A by B, means larger side of the duct to the smaller side of the duct. Ratio of larger side of the duct A to smaller side of the duct B. This is the aspect ratio. If the important factor to be considered in design purpose of duct, aspect ratio. The effect of aspect ratio is given by different figure. The aspect ratio for rectangular duct should not be greater than 8 in any cases. This is a knot of the design of duct. This aspect ratio should not be greater than 8. I will draw a 3 aspect ratio curve of, first is, this is a curve gradually increase. This graph is indicate percentage increase in heat gain or say loss to aspect ratio. Graph is gradually increase. Second graph is percentage increase in installation cost by aspect ratio. Percentage increase in installation cost by aspect ratio. This curve is start from here and gradually increase. Third one is percentage increase in operating cost and aspect ratio A by B. Graph is starting from O point and gradually increase. This three graph is used to design the duct. Third effective layout is duct friction. If duct friction rate is higher, the higher will be the size and aspect ratio. This will increase the initial and running cost. This is a factor affecting in duct design. If duct friction rate is higher the aspect ratio and initial cost will be increased. Fourth one is type of fittings. Types of fitting. The fitting can be divided into class A and class B. It is described in graph. Different fittings are used in duct like elbow joints, okay, etc.